Hello students, here is Divya Singh, Assistant Professor, School of Computer Application, BBT University. So now we see prepaid electronic systems. In this we see eCash TM, Mondex, Millicent TM, Micromint, NetBill, MiniPay, Netfair and CyberCash. Now see first that is eCash. That is, eCash is a purely software based, anonymous, untraceable online token payment system available on Unix, Windows, as well as Macintosh platform. Customers as well as merchant require graphical wallet software that can also be accessed via a command line interface. eCash allow for bidirectional payments. There is no distinction between customers and merchants with regards to payment. Both sides can give and receive payments. So now, however, since the system is coin based, it requires clearing of coins by its issuing bank. The implementation of various transactions with eCash TM are as follows. That is, first is withdrawal, then purchase, then customer to customer, and next is privacy protection. Now, see first that is withdrawal. There are two participants in the withdrawal transaction, the bank and the customer. The customer connects to the eCash TM issuer and purchaser electronic coins of the required value. These coins are generated involving the blind signature scheme to make the token anonymous. The customer generates the token IDs, blind them, determines their denominations, transmit them to the issuer that blind sign them and return them to the customer who in turns unblind them and store them on his PC in a wallet. No physical coins are involved in the actual system. The messages include strings of digits, and each string corresponds to a differential digital coins, with each coin having a denomination or value. The wallet of digital coins is managed automatically by the customer's eCash TM software. It decides which denominations to withdraw and which to spend in particular payments. That is, the eCash TM software keeps plenty of small change but will prompt the user to contact the bank in the rare event that more changes is needed before the next payment to restructure in wallet of coin denominations. Next is purchase. Now see what is purchase. On once the customer has some eCash on his hard drive, he can buy this from the merchant shop. If the customer show the intent to purchase a product, he receive a payment request from the merchant which he has to confirm. His eCash TM software chooses coin with the desired total value from the wallet on his hard disk. It then removes these coins and sends them over the network to the merchant shop. When it receives the coin, the merchant software automatically sends them on the bank and waits for acceptance before sending the goods to the customer along with the receipt. The To ensure that each coin is used only once, the bank records the serial number of each coin in its spent coin database. If the coin serial number is already recorded, the bank detects that someone is trying to spend the coin more than once and informs the merchant. If, as is usually the case, no such serial number has been recorded. The bank stores it and informs the merchants that the coin is valid and the deposit to accept it. Next, that is customer to customer. When the customer receives a payment, the process would be the same, but some people may prefer that when they receive money, it be made available on their hard disk immediately ready for spending. The only difference between this payment from a customer to another customer and the earlier one is that happened after the bank accepts the cash. Once the second consumer has configured his software, he requests the bank to withdraw the eCash TM just deposited and send it back to his PC as soon as the coin are accepted. That is actually the second customer's bank will check the first customer's bank to make sure the coin deposit are good or not. The generation of token IDs by the customer could lead to duplicate token IDs by different customers without double spending having occurred. But by using a sufficient long token IDs, that is 100 unit, this is made highly importable. Pictorially, these transactions can be summarized as shown in the figure below. In this figure, we see that there is a customer who is signed unblind token and will transact flow in eCash system and gives the eCash token and merchant give the invoice and goods delivery back to them, and customer with the blind token withdrawal gives the eCash broker and eCash broker gives the signed blind token and as a acknowledgement. And on the other hand, the merchant double spending check returns results and with it acknowledged with the eCash token. Next, that is in this, the privacy protection blind signature in the simple withdrawal described earlier, The bank creates a unique bank digital coins, validates them with its special digital stamp, and supplies them to the customers. This would normally allow the bank, that is, at least in the principle, to recognize the particular coin when they are later accepted in the payment, and also it exactly with their payments were made by the customer. By using blind signatures, the bank is able to validate coin without tracing them to a particular account. Instead of bank creating a bank coin, the customer's computer creates the coin itself at random. Then it hides the coin in a special digital envelope and send it off to the bank. The bank withdraws $1 from the customer's account and makes it a special worth $1 digital payment validations like an embossed stamp on the envelope before returning it to the customer's computer. Next is Mondex. The Mondex purse is the smart card alternative to the cash. The Mondex purse is self-standing value store, requires no remote approval of individual transactions. Better individual transactions, rather the Mondex value equivalent to the cash is stored in the card microchips. The purse also stores secure programs for manipulating that value and for interfacing with other Mondex card or terminals. After withdrawal from an ATM, the value money can be transferred from one card to other via a special password protected electronic wallet. The first implementation of Mondex support up to 5 different currencies, each separately accounted for by the card. The Mondex system use the following hardware, that is, the Mondex smart card, the Mondex retailer terminal, that is to transfer funds from the customer to the merchant terminal. Next is Mondex Wallet, a pocket-sized unit to for store large sum of digital money than the card. Next is Mondex Balance Reader, a small device to reveal the balance remaining on the Mondex card. Next, Mondex Hotline to access the bank account and to transfer money to the other cardholders. Next, Mondex ATM, that is automated teller machine to recharge card or to transfer money back into the account. Now see the transactions. The transactions are the sequence of steps in a particular transaction is the customer loads value to the money. The customer loads value to the money onto the card either from an ATM machine or from a phone. Next, the purchase on the item, the customer provides this card to the merchant, point to the sale device and authorize the transfer of the certain value. The amount is electronically detected from the chip inside the customer card and added to the amount in the retailer chip. This is implemented with this diagram. This is diagram which shows the transaction flow of Mondex system. Now see third is Millicent TM. The Millicent TM is a proprietary digital micro-commerce system from digital equipment provides a way of buying and selling contented content in very small amount. Over the internet, the system support transactions as small as one tenth of the cent up and the dollar 10 or more. The valid system uses crypts or form a token that is only valid with specific vendors for a limited period of time, and brokers who act as intermediaries between vendors and customers. The fact that any particular type of scripts is only valid at a particular vendor means that the vendor does not need to connect to the separate issuer to validate the token, thereby reducing network traffic and eliminating the accompanying cost of such a validation. Brokers acting as intermediaries, maintaining a long term relationship with customers and merchants in this system. Next is transactions. In this, the basic sequence of transactions is as follows. The customer acquires a quantum of broker scripts in the beginning. The customer needs a specific vendor script. The customer requests for it and pay for it with a broker script. The broker acquires the required vendor scripts from the vendor. The broker transfers the vendor scripts to the customer to exchange for a broker script. The customer buys the service from the vendor with the vendor script. And last, the vendor returns any change to the vendor script. In the last first four steps for acquiring the script, in the case the customer purchases sufficient scripts from his broker to meet his need for a period of time, these steps need not take place in every transaction conducted during that period. Similarly, the broker may have enough vendor script to service a number of customers' requests or may have a license from the vendor to mint the specific vendor script directly. These transactions are given in these diagrams. Next is security. Since Millicent TM is targeting the micro commerce segments, it does not have to use expenses tight security mechanism. The Millicent TM offers three protocols ranging from private and secure at the top level. Although the secure without it, although though secure without encryption, to script in a clear at the most basic level. Basically, the system uses shared secret and one-way hash function. For example, in the secure without encryption mode, the customer has the vendor both known the customer secret, and this secret is appended to the transaction request from the customer to the vendor and hashed. The hash value, that is signature, and the request are sent to the vendor who recomputes the signature from the transaction request and his copy to the customer secret. If the two signatures matches, then the request is validated. The amount involved in the millicent TM transactions are small, thus negating the risk of non-compliance with automaticity, the consistency and durability requirements, although each vendor has its own proprietary script. Interoperability of the system is assured at two levels, that is, first, because many vendors will use the same broker, there is vendor interoperability, and second is to assure the cooperation among the different brokers to make a locally brokered script more generally available. The property is drawn into the question simply because individual vendor issue their own script and are therefore free to issue to reinterpret its purchasing power as they see fit. Next, fourth is micromint. The micromint is a payment mechanism for making small purchases for over the internet. The main goal is to minimize the number of public key operations required per payment. To support micropayments, exceptional efficiency is required. Otherwise, the cost of the mechanism will exceed the value of the value of the payments. As as a consequence, the micromint is not robust as far as the security is concerned, is comparison to full micropayment schemes. Next is transaction. The participant in the micromint transactions are brokers, customers, and merchants. The brokers authorize customers to make micro payments to merchant and redeem the payment collected by the merchant, while customer merchant relationship are transient, broker user and broker vendor relationship are long term. Next is security. The security mechanism is primarily designed to discourage, discourage large scale attacks such as massive forgery or persistent double spending. These some methods are to the messages. Some methods are to discourage such large scale frauds. The methods are: all fraudulent coins automatically become invalid after the end of the month. Forged coins cannot be generated until after the broker announces the new monthly coin validity creations at the beginning of the month. The broker can detect the presence of a forger by noting when he receives coin corresponding to the bins that he could not produce coin from. Next, the broker can anytime declare the current period to be over, recalls all coins, all the current period, and issue new coins using a new validation procedure. The broker can simultaneously generate coins for several future months in a longer computations. This makes it harder for longer to catch up with the broker. Now next is fifth is net bills. Net bills has been conceived to address the problem of buying information goods over the internet as opposed to the physical goods purchased on the internet and shipped later by the merchant. The information goods are themselves transferred over the internet to customer. Preferably, this transfer should take place immediately after purchase. Hence, the issue to be addressed in such a transaction are very different from these on transaction involving physical goods. Next, the transaction. See in the following figure, a customer buys information goods from the merchant. The merchant sends good in encrypted form to the customer. And next, the customer software verifies that the goods were received correctly and send validation of this to the merchant software. Next, the merchant submit the validation message received from customer and account information provided by the customer and the description key to the NetBill server. Next, the NetBill server verifies that the customer has sufficient money to the account to pay for the goods. In case of sufficient funds, it transfers fund, stores the decryption key and send the report to the merchant software. The merchant then sends the customer decryption key, which the software of the customer machine uses to decrypt the goods. In case of merchant server fails to deliver the decryption key, the software on customer servers can acquire the key from the NetBill server. Next, that is security. The NetBill uses a combination of public key cryptography and symmetric key cryptography to make sure that all the NetBill's communications are secure and all the transactions are authorized. NetBill's approach is based on the well-tested Kerberos protocol, which has been widely used for nearly a decade by most major computer manufacturers. The Kerberos is a network authentication system for the use on the physical ensure network based on the key distribution level. In the key distribution model, it allows entities communicating over the network to prove their identity to each other while preventing eavesdropping. It also provides a data stream integrity, that is detection of modification and secrecy, that is preventing unauthorized reading using encryption using cryptography systems such as DES, that is Data Encryption Standard. Kerberos work with providing the principals, that is user or service with tickets that they can use to identify themselves to other principal and create secret the cryptographic keys for secure communication with other principals. Next is MiniPay. MiniPay is a micropayment solution developed by IBM. The objective is to provide an open standard and low cost toolkit for vendors with the aim of reducing the payment transaction cost. The MiniPay system minimizes the interaction cost among the customers, vendors, acquirers, and clearing by taking advantage of their online presence. Next is transaction. In the figure below we see that in the figure this we see that the issuer sends each customer a daily spending and authentication certificate each morning at login time. The customer ready to make a payment for selected goods click on the designated MiniPay link at the merchant's website. Next, a MiniPay merchant payment order signed by the issuer is generated. This payment order includes the current customer information certified from the issuer. The merchant verifies the signature of the issuer and checks the recommended offline spending limit indicates in the certificate. Next, if the daily spending limit is not exceeded, the merchant immediately delivers the request information and store the payment uh, order offline. If the daily spending limit is exceeded, the merchant contacts the issuer to confirm the payment order. The issuer can confirm orderly the request. Next, at the end of the day, the merchant sends the aggregated payment order to the acquirer for clearing. The acquirer aggregates the payment of its merchant and submit them to the issuer for clearing. The clearing process allows for additional billing service between the acquirer and the issuer to act as exchanges each day at the login time. The customer contacts its issuer and they sign the balance and the sum of the purchases to each other so that the other records can be deleted. Next is seventh is Netfare. The Netfare is the information access card that operates like a public transportation fare card or a telephone access card. A typical operation can be described as follows. First is the customer purchases a card for whatever amount is desired. Next, the consumer presents the card to the merchant to pay for electronic information at the point of delivery. And third is the merchant calculates the customer bills and checks that there is enough credit remaining on the card to pay for desired product. And the fourth is the product is delivered to the customer electronically, that is for example by sending an email contacting the product, downloading a file, providing access to protected website pages, etc. The Netfare card is specifically geared for access to desired mercantile sites, for downloading products over the internet, for using the Netfare payment. The mechanism the merchant has to do, that is the to establish a Netfare merchant amount. Next, the use of Netfare provide HTML code to link the payment points to the Netfare systems. Next, establish the price and goods that are to be sold. The Netfare server respond with a go or no go answer. If there is go, the merchant delivers the product, and if there is no the go, the merchant just displays the error message to the customer. Next, once the month or more frequently the last site volumes, the merchant bank account is credited with this payment. For the customer purchases a Netfare card is a card of the denominations that he requires. The customer shop with this card at any participating merchant. He needs to enter his Netfare card number and personal identification number. And the customer can check his Netfare balance online at any time. Next, last is cyber cash. The cyber cash include founded in 1994 provides a means for secure financial transactions over the internet with its secure internet payment service. Three software components are involved in CyberCash transaction. That is, one component, the CyberCash wallet, is for user's PC. One is that the merchant's server, and the third component is within the CyberCash server. The first and second software components are freely available. There are two system cyber cache umbrellas. That is, one is cyber cache system and second is cyber coin system. The cyber cache essentially a gateway to tie in the internet merchant to exist electronic payment system to protect the credit card transaction through encryption based protocols and is a postpaid payment system described later. The cybercoin system designed to define transaction and support micro payments. The it is a system is designed to serve the micro payment segment. It lower bound to the payment in 25 cents, which contracts with the usual notion of the micro payment as a subset transaction. Part of reason that this lower bound is so high is that the system uses a public key to combination with the symmetric key encryption. Also, merchants are changed in the per transaction basis, which serves to keep the lower bound higher than it might be otherwise. In addition to the system is not implementation coin in the strict sense of the term, as in the notational rather than the true token system. The value is never held in the customer's PC. The money stays within the existing banking network, and what the customer has on his computer in the legal record of the money. The advantage of such an approach is that should the customer computer crash, the money is unaffected. However, Cybercoins does not support customer to customer transactions. Moreover, the system is not anonymous as transactions can be tracked. Now, thank you for listening.